All right, guys, so today we're talking about polynomial long division. We're also going to talk about synthetic division, and we're also going to talk about both direct and synthetic substitution. And so we're going to look at these two different methods of substituting values in our equation or into a function first. Okay, so let's say I gave you a question we have an idea how to answer, like find f of -3 if f of x equals this polynomial. Well, what does this mean again? It means to substitute in -3 everywhere we have x. And the method of doing that is called direct substitution. We're just directly substituting in for x. So we'd write our polynomial out. Everywhere we saw x, we'd plug in -3. One word to just be careful with this. So say we were doing specifically this calculation, -3 to the fourth. Be very careful when you put that in your calculator, because if you put it in like this, -3 to the fourth, it's going to give me back an incorrect answer as far as what I wanted. So the calculator is reading this as the opposite of 3 to the fourth. And so it's giving me back -81. When I really wanted the number -3, which we'll need to use parentheses to do this correctly, the number -3 times itself 4 times. And that results in +81. So just be careful, especially when you're plugging in with negative numbers to a power. Make sure you're correctly using parentheses there. All right, so we plug that in. -3 to the fourth is 81. -3 cubed is -27. -3 squared is 9. Okay, so we've done all our exponents. Now we're going to multiply. 2 times 81 is 162. -3 and -27 is 81. 2 times 9 is 18, and then -10. And if we add all these together, we get 251. Okay, so we plugged in -3, and after doing all of this extra calculation, we get our answer of 251. So that does tell me a point on the graph, -3 for x, 251 for y. But there's a faster way of plugging in, and that's this method called synthetic substitution. Okay, so we're going to do the same thing. We're going to plug in -3 into the exact same polynomial. So here's how the setup of synthetic goes, though. We're going to kind of create this little half box in the top left corner. And in that box, we're going to put the number we want to plug in. So in this case, -3. Okay, then we're going to look at the highest degree of my polynomial, which is x to the fourth. We're going to set up a placeholder for x to the fourth, x to the third, x to the second, x to the first, all the way down to x to the 0, aka our constant. So that's why I wrote a big C there. And I need to make sure I have a placeholder for all of those. So if I happen to be missing any terms, and in this case we actually did not have an x to the first term, we do need to put a 0 there. And what we're writing down are just the coefficients. So these are the numbers from the front of our variables, right, or the multipliers on our variables. So 2 for x to the fourth, -3 for x squared, for x cubed, 2 for x squared, 0 for that missing x to the first, and that's why I like setting up these labels. That is important. And then -10 for my constant. Okay, so then we leave a line of space. We're going to put some numbers in this row. We'll put kind of like a little total bar here. I like to add an addition sign to remind myself to add things above this line. And we start this algorithm by dropping down the very first number. Okay, so we drop down our first coefficient of 2. And a rule is anything that comes below this line, we're going to multiply by the number in the box. Okay, so 2 times -3, and we write our answer underneath the next number. So we get -6. Okay, and then we're going to add. That's why we put our little addition sign here. We're going to add these two numbers. So that gives us -9. And then we multiply by the number in the box. -3 gives us +27. Adding those together gives us 29. Multiply by the number in the box. This is a little more difficult, but that's -87. Check that with your calculator. Adding that with 0, we get -87. -87 times -3 ends up being 261. And +261 and -10 gives us 251. And hopefully that looks familiar. It's the same answer we got with direct substitution. But this method is much, much faster. It has much smaller number of calculations. I know there's a few big ones at the end, but overall, this method is going to save us a lot of time once we learn how to set it up. So again, the number we want to plug in goes in the box. We figure out our highest degree and set up a placeholder from that degree all the way down to x to the 0. Make sure we write our coefficients for each term, keeping the signs of each. And if we're missing any terms, it's really important to put that 0 as a placeholder. We drop down the first coefficient, multiply by the number in the box. That gives us the next number we put under our next coefficient. And then we add. Multiply, add, etc. So it ends up being pretty fast because we're doing our two quickest operations, which usually you can do in your head or faster with the calculator. Okay, we got one last part on our note sheet here, which is talking about synthetic division. So that same synthetic algorithm we did earlier, we can use actually to divide in some cases. So if our divisor is a linear binomial, dang it, did it again. Linear binomial. So that means it's x to the first power is our highest degree, and it has two terms. And its coefficient has to be a 1. So 1x to the first, plus or minus some whole number. Okay, so if we're dividing in with these kind of specific looking cases, then we can use synthetic division. And it uses this algorithm that looks just like synthetic substitution. The only difference is, by the way, if you look at the previous problem, let's say we wanted to divide this polynomial, which is what we did in the last example, and divide it by the answer we got, x minus 3. What should my answer be? Well, I think we should get 2x squared minus 5x plus 3. And what would our remainder be? It should be 0, right? Okay, so I'm going to show you this process with synthetic. All right. The first thing we need to do, though, is we need to take our divisor and set it equal to 0 and solve. We need to find its 0. So if you set this equal to 0, I'd have to just add 3 over, and we get positive 3. Okay. This is called the 0 over divisor, and that's the number we put in the box. So it's the only thing that's different. We're not plugging in 3, we're dividing by x minus 3. Okay. So we take our original coefficient, again, x to the third is the highest degree, so we put a placeholder for x to the third, x to the second, x to the first, down to the constant. And we write in our coefficients, 2, negative 11, 18, negative 9. We weren't missing any, so we didn't need any zeros for placeholders. Okay, then we drop down our first coefficient of 2 to get us started. And if you remember from the beginning of the video, we're going to multiply by the number in the box with anything below this line. So 2 times 3 is 6, and then we're going to add, which gives us negative 5. Negative 5 times 3 is negative 15. When I add, we get positive 3. And 3 times 3 is 9. When I add, we get 0. And so if you look at these numbers, 2, negative 5, 3, 0, and look at what we're expecting our answer to be, 2x squared, negative 5x, plus 3 with the remainder of 0, we can see all those numbers right here. And in fact, this last calculation tells me the remainder. The number just to the left of it will always be our constant, or x to the 0. This is the coefficient of x to the first. This is the coefficient of x squared. If there was another number, this would be the coefficient of x cubed. Another one, x to the fourth, etc. But this last number, it's always the remainder, constant, x to the first, x to the second, etc. Okay, obviously we don't really have an x to the third term. That was just to cover some other cases. So as we write our answer, it's 2x squared minus 5x plus 3 with no remainder. And that's what we expected to get when we divided by the other known factor, x minus 3. Okay, so let's try one last example. I know this has taken a while. Okay, this is a good candidate again for synthetic. It's 1x to the first power plus or minus a nice whole number. Okay, so remember the first thing we got to do though is take our divisor over here and find its 0. So if I add 1, x has to equal positive 1. That's the number that goes in our box. And I'll put a plus sign just for emphasis. Okay, so x cubed is my highest degree. We'll set up a placeholder for x cubed, x squared, x to the first, all the way down to x to the 0, aka our constant. And we'll write in our coefficients. We've got a 1 x cubed, negative 4 x squared, positive 2x, and positive 7. We'll leave one line of space and put our plus sign, and then drop down our first coefficient. Okay, 1 times 1 is 1. And then when we add, we get negative 3. Negative 3 times 1 is negative 3. When I add, we get negative 1. Negative 1 times 1 is negative 1. When we add, we get 6. And so this 6 is my remainder. So that tells me it did not divide nicely. X minus 1 is not a factor, but we can still write our answer. Okay, remember that this is our constant, x to the 0, or the constant. This next number is x to the first, and this is x squared. So writing our answer, I'll try to squeeze it in over here. We have 1x squared minus 3x. Oh, I'm not going to have space here. Hang on. We'll squeeze in the very bottom. Sorry. Maybe we'll write it up here. We'll write it up here so you can see it better. X squared, 1x squared, minus 3x, minus 1, plus our remainder over the divisor, which was x minus 1.
All right, let's do a couple more examples here of synthetic division. So again, if I'm dividing something by a linear binomial, so again, this is linear because it's x to the first is the highest degree. It's only got a 1 in front of it. That's our other check. And then it's plus or minus a number. It has to be just x plus a number or x minus a number. Okay, those are our only setups where we can use synthetic here. So what we need to do, again, to find the number that goes in our box is find the 0 of my divisor. So if I set this thing equal to 0 and solved by adding 1, we'd get positive 1. So that's the value that goes in that box in the top left. Next, we look for the highest degree in our dividend, which is x cubed. And we're going to set up a placeholder for every power all the way down to x to the 0, aka our constant. Okay, and our coefficients here are 7, negative 17. Remember to keep the signs with them here. Positive 8. I guess I don't need the plus sign. Positive 8 and positive 2. Okay, so now we're ready to get our algorithm going. And again, the way we start this, we drop down the very first coefficient. And anything that comes below the line, we're going to multiply by the number in the box. So 7 times 1 is 7. And we write that underneath our next coefficient. So again, 7 times the number in the box. Give a 7 and we're adding. Negative 17 and 7 makes negative 10. Whoops, let's stay green here. Okay, again, remember anything below the line gets multiplied by the number in the box. So negative 10 times 1 is negative 10. Write a result underneath the next number. And then we add, right? We're going to add these two numbers together. Gives us negative 2. Times the number in the box gives me negative 2. And we add, we get 0. Okay, so this is actually an example that we did in our polynomial long division live session. So remember that this last value here is our remainder. This becomes x to the 0, or our constant. This is the coefficient of x to the first and the coefficient of x squared. So writing our answer, we get 7x squared minus 10x minus 2, that's just our constant, with the remainder of 0. So we can omit the remainder and just write our answer as 7x squared minus 10x minus 2. We got a beautiful no remainder answer. Okay, let's try number 8. Number 8 here, we're going to do the same thing. Again, check that this is a linear binomial, just a 1 in front of our x, and it is. And then we're going to take this off to the side and find its 0. So here, setting it equal to 0, we get positive 9. So it's positive 9 that goes in the box here when we want to divide. I look at my dividend. My highest power is x cubed, so we're going to set up a place for x cubed, x squared, x to the first, and x to the 0, aka my constant, so all the way down. Remember again, if we're missing any terms, we need to plug in a 0 as a placeholder. That is important. Don't forget our plus sign here. All right, and let's fill in our values. So we have a 1 in front of x cubed, negative 9 in front of x squared. Ooh, we don't have an x to the first term, so we do need a placeholder of a 0. We have 0x to the firsts, and our constant, negative 5. Okay, so we have our setup ready to go. Remember, to start this off, we just drop down the very first coefficient. Multiply by the number in the box, we get 9. When we add, we get 0. 0 times the number in the box is 0. Adding, we get 0. 0 times the number in the box gives me 9. And when I add these two together, we get positive 4. So let's interpret our answer. Remember, this very last calculation is our remainder. This would be x to the 0, or our constant, and x to the first, and x to the second. So we have 1x squared. We don't have any x to the first, so we can just omit that term or leave it out. We don't have any constants either. So we just end up with x squared with the remainder of 4. So remember, we write it when we have a remainder as the quotient plus remainder over divisor. So this was my quotient plus our remainder, which is 4, over what we were dividing by, x minus 9, our divisor. And so this is how we'd write our answer. Again, we did this in our live session, so you should have this one in your notes already for long division. This was just an alternate way that proves to be a little bit faster once you get used to our algorithm. So x squared plus 4 over x minus 9. Okay, for number 10 though, remember that if we're dividing by something that's not linear, I cannot use synthetic. You would have to use long division to do number 10. Okay, so we're not going to do that one. We should have already done this in class together, but just an example of something that you couldn't use with synthetic. If you have something like this, it's what you're dividing by. There is a way to use synthetic, but we're not going to learn it because it has, 1, a lot of fractions, and then 2, you'd have to come back and divide your answer by 3. It's a mess. So we're going to say no. Don't do synthetic. Use long division in that case as well.